Hello. Uh, Welcome to another contact session of ours. Of course, we had it a day earlier than the normal schedules, but thank you that you people have joined, taken up your time and joined in. So the last session we spoke about how fecal sludge and septage management right way impacts on the environment and the economy, and then we saw an example of the Tomogote city. And then we also heard Professor Dr. Hashimoto-san when he spoke about Japan's sanitation experience of Jokaso and how Jokaso came into being and how Jokaso Act has been implemented. Now, keeping in line with that, let's come back to our countries a little bit. And today we will talk about here in our country, how in India, we started thinking about fecal sludge and septage management specifically, and then how policies have been developed, what are the principal highlights or what are the key focuses of the policies. And then later part of the session, we would go through if there are policies, if there are treatment technologies coming up, what are the standards, how they are obtained, and what are the ways to do it, and what are the key things we should look into while maintaining the quality of these fecal sludge and septage management plants outputs. Having said that, I would hand it over to Professor Chari to take us through the policy development environment which happened in India and then consequently what happened in the state of Telangana where we precisely work on. Thank you so much. Over to you, Professor Chari.
Thank you, friends. Good afternoon. We generally undertake the session on Saturday, but because of the holiday tomorrow, we are doing it on Friday. We will again switch back to Wednesday and Saturday a little later after the session. Last week we had this week rather we had Japanese regulatory framework on on-site sanitation. Now we heard some things. We heard about how they introduced the act where every household has to introduce an on-site system, and then how it is monitored, how the empanelment takes place. All of those ideas we have discussed. So today, let us translate that understanding into operational steps. How do we go about it? How do we achieve sanitation improvement? And what, for achieving any improvement, you need to have the right kind of policy and regulatory framework. I will explain in detail in a very simple way. Why do we need it? Okay. So sanitation improvement by default will not happen. It requires a very strong leadership, both political leadership, administrative commitment, to translate that leadership into a policy and policy to regulation. So today, as more and more people join on this, we will specifically discuss about if the city has been, and many of you
Did we lose, sir?
Probably.
Yeah. Okay, just give me a second. I'll check with him.
I'm sorry. So I lost a bit of time now. I think it's, yeah. So what we will do is, we will start thinking about, as city leaders, as practitioners, as engineers, as planners, why do we need a regulation? And what are the key aspects of regulation for improving sanitation? Now, we started our introductory sessions by defining the CIVIS framework, Citywide Inclusive Sanitation Framework, where we want to achieve equitable sanitation, not only for select people, but equitable for vulnerable population, for children, for men. And we want high degree of safety standards. Safety for workers, all of that should be achieved. And we want this to be delivered on a sustainable basis, both financial sustainability and environmental sustainability. That's our expectations. We want equity, safety, and sustainability. To deliver that, you need certain systems. What are the systems? You need a responsible entity. You need that entity to be accountable. They should be tracked and their performance will be monitored. And then you need a continuous resource planning and management. You need cash, you need money, you need human resources. Now, this is what we discussed. ISKCO, if you want to make it implementable, this approach of citywide sanitation, where we achieve universal access to sanitation, safe sanitation, not toilet, safe sanitation, with high degree of standards, treatment standards, and sustainable, not for 1 year, 2 years, but forever. You need a good governance. You need a clear policy directions. Now, what is a policy? A policy is a statement of intent implemented very clearly as a procedure or a protocol. The policy is a statement of your intent. Now, many governments have introduced policies, but often it is not getting implemented. In fact, there are people joke, oh, policy is good, but never gets implemented. It has to be backed up with a clear rule or a directive issued by the content. It has to be defined by rules of the game. The rules, you have to do it in a time-bound manner. Who is responsible to do it? If you don't do it, what happens? Those are all rules and directives. For example, water should be made available to the urban poor a minimum quantity of 5 kiloliters. If there is just a policy, it may or may not work. But if it is a rule, then the water utility has to deliver it. It becomes a right on the part of the citizen to expect that 5 kiloliter water free per month. So similarly, your safe sanitation should have a clear direction and a clear regulatory support backing up. Otherwise, it will not be achievable easily. It may achieve, but it may not be equitable. We may set up a treatment plant, but without the rules, the treatment plant will not be delivering the desired outputs. Unless there is a regulation to say that you have to bring it down to 10 BOD. So, friends, we need to start thinking about rules, framing of rules in the context of citywide inclusive sanitation. So today what I will discuss is some of the components of these rules that you have to keep in mind. If you are drafting a policy and regulations, you need to keep these points in consideration. Now, you come from a city. Here is the city of Hyderabad, where I come from. Now, this is a big city. It could be a small town also. There are different ways of delivering sanitation. As we discussed, one is if the city is rich, the old part of the city, you can put up a small sewer system. Then the city is growing very fast. The buildings and peripheral areas are growing very, very fast. You need to have decentralized systems because you may not extend your sewer systems. Then there are still many areas where the decentralized wastewater treatments may not be viable. That's when you go for septic tanks and on-site systems or leach pits. In all this, we want to prevent open defecation. So, how did we frame policies and rules in the context of Hyderabad? I will use a case study so that to communicate to you how important it is to define right kind of policy and right kind of regulatory framework for successful implementation of FSM or citywide inclusive sanitation. Now, first thing is what we did. Hyderabad is growing very fast. It is also growing vertical. Now, sewer systems cannot go. Water is not available. Water utility doesn't have money to extend the network. But because of the cheap land prices in the peripheral areas, the buildings are coming up because of the economic activity. So what did we do? We created a in situ regulatory framework for decentralized on-site systems in Hyderabad. What does it mean? It means that the treatment shall be at the point of generation of the, and on top of it said the treated water should be necessarily used in the same building. Friends, this is called net water neutral buildings. What does it mean? Not only treatment, the fecal waste and the wastewater, not only it gets treated, but it gets recycled in the building to reduce the pressure on water resources and to minimize the pollution going out. So what did we do? We framed a regulation in Hyderabad called Hyderabad Decentralized Sewage Treatment and Water Reuse Monitoring Regulation 2023. What is the objective? The objective is to achieve net water neutral buildings by promoting on-site used water recycling through monitoring and evaluation of decentralized STPs. So what do we mean by this? For example, there is a building. For example, there's a building coming up. This is a low-income housing. Now, there are two options here. I can put up a septic tank, huge septic tank, or I can go for a decentralized wastewater treatment. Here, our regulation is to go for decentralized wastewater treatment. The wastewater, both feces as well as the water, used water will come out. We treat it, recycle it, and reuse it. Similarly, what is net neutrality buildings? This is also part of regulation. Whatever water is required for the building is coming from the treated water through recycling, flushing, chilling, all that. So the requirement of fresh water comes down. How did we achieve it? By introducing what is called a regulation which says that every building, residential building with 25 dwellings or 5,000 square meters should have its own treatment plant. Commercial buildings, they should have its own treatment plant. Hotels, they should have their own treatment plant. Restaurants, they should have their own treatment plant. Hospitals and healthcare facilities, own treatment plant. Gated communities, absolutely, all of them. They will not be let into the environment. They have to set up a treatment unit within that particular premises, like the way you have space for parking of vehicles, parking of cars in a building. You need to have a parking space for STP. And that water gets recycled back. Now, what about the existing buildings? For existing buildings, they have to go for a transition within a 2-year period. Within 2 years, they have to put up their plants. They cannot let out feces into the nalas and drains and water bodies. They have to have their own treatment plant. This is one model. I'm not saying this is applicable for a 10,000 population town. This is applicable in Africa or XYZ place. But for capital city, this is one of the regulatory framework we have promoted. Now, if there is a sewer system within 50-meter distance, the building can be connected to the sewer system. But if it is not so, they have to set up their own on-site system. So what is the implication of all this? The implication is the regulation should think how to achieve sanitation improvement for bulk waste producers, bulk users of water and wastewater generators. One model of regulation we have chosen is in situ treatment with rapid recycling. The plumb system. Dual plumbing means one for drinking water, one for treated water. The treated water again will go back to the house and we use it for flushing. If I'm flushing the toilet, I'm not using the fresh water. So it gets recirculated. How did we achieve this? Through a good regulation. This is what I mean by regulation. Okay, this is another piece of regulation we are now attempting. All schools, hospitals, they should have their own in situ Jacasso type systems. This is the 50 KLD plant. When you come to Warangal, you will see it under construction. It was under construction, now it's completed. So the water gets treated and used for agriculture, urban agriculture, or for gardening purposes. This is another way of addressing. So you need to start thinking about how do I deal with sanitation improvement through regulation. So one approach is decentralized used water management. Now, okay, there's another approach where we have a lot of on-site public on-site toilets. We have septic tanks, we have leach pits, many of them, because for high-rise buildings, we can have STP, sewage treatment plant through regulation. But for individual households, they can't afford. So we went for on-site septic tanks and on-site twin pit toilets. Now there is a problem we discussed. The problem is that the waste coming out of these on-site systems have to be carried forward systematically, treated, reused. That is a fecal, sludge and septage management. Warangal and Telangana is the one of the first few states and cities which have introduced a city level regulation to deal with the unsafe sanitation practices. And these are the critical components of regulation for improving sanitation. Design and construction of septic tanks. The question you need to ask, and we all need to ask, septic tanks are anaerobic digesters. Are they designed as per the standards? And the regulation says that as per Indian standard IS 2470 in India. Bangladesh has something else. Pakistan has something else. As a building, Africa has many of those. They are based on the occupancy of the building. In Nepal also it is common. Based on number of people living in the building, the length, breadth, depth of the septic tank is defined. If anybody is interested, we will be happy to share. Now, very important in this regulation is the outlet of the septic tank should be connected to soak away. Otherwise, it is a completely useless technology. Are we following it? So now, this design of septic tanks for new buildings, we have integrated in an online module of a building approval system. The citizen has no choice. They have to upload the map, the system checks, and if the design is as per that, then it will give a no objection certificate or a permit for the building. So the first piece in your journey for drafting the regulation is that your containment system should be designed as per a good regulatory scientific process. And this has to be communicated to the citizens, to the masons, to your stakeholders, the do's and don'ts of septic tanks. Because there is a science behind a septic tank, and if that is not followed, it is going to kill us. It is going to, it is full of, pollution. As I said, you may need to educate your citizens, and that is an important component of our regulation. The citizen can reach out to the city authority through a toll-free number to say that if you want to design and construct a good septic tank, please reach out to us. Please establish this as part of your regulation, a call center for educating the citizen. You can see in our regulation, there are 9 components. One of the components is helpline for septage management, including design support for citizens. Because if your point of generation is sound, then the pollution downstream is also less. Step 1 is over. We have to build a credible, well-designed septic tank is what you are communicating to the citizens through a regulatory framework. Second thing you need to do, like in Japan, who should build the septic tanks? Like Japan is so clean because they have trained and empaneled people who can build their jokaso or install their jokaso. We also need to have empanelment of masons who are building these septic tanks, training them, certification, certifying them. Only those people should be used for construction, and city authorities should put their names on the website so that citizens can engage them further. This is the second important step of regulatory. The third important step of regulatory framework is what, right kind of people are trained for construction of septic tanks. Then you need to have right kind of people to evacuate, desludge and evacuate your septic tanks. So what do? The regulation says that only empaneled desludging operators who are trained, certified, are expected to work in the city, and they are licensed. This is called license to operate. Vijay Saab, you need to bring that regulation where it says not anybody and everybody can lift the fecal waste, but only licensed desludgers are expected. That's part of your regulatory. So there'll be a code, there'll be a number, they get a license certificate, and then they only can move in the city. Otherwise, the vehicle will be seized. It is like having a driving license. It's a part of the Motor Vehicle Act. Like that, as a part of the septage management regulation, you need to have that permit to operate in the city. And they should have mandatory personal protective equipment imposition. They cannot go to work without this PPE. That's a part of the permit. That's a part of the SOP, standard operating practice and approval system. This has to be embedded in your regulation. Step 3 is this. We have covered 3 steps of regulation. The 4th step of regulation in the context of FSM is the route planning and route navigation. They should have a GPS system and they should navigate in a particular way. Why do we need to do it? Because it is a hazard. Not result in leakages, so we need to regulate this also. Tracking the vehicle is a part of the regulation so that they don't discharge in the nearby water body or in the open areas. It requires regulation. This is the 4th step. The 5th step of regulation is record keeping. As we all discussed, like in Nepal, Pakistan, India, Africa, and many other places, the periodicity of regulation is desludging is defined in the codes of practice of septic tanks. So for that, you need to have a record. You need to have a system of understanding which household got desludged today, so that we can send an alert after 2 years that your septic tank is ready for desludging or should be desludging, like in the case of Japan. So that the city or a private or a public authority can send the truck and then again desludge. For that, you need to have a record. It is like a vaccination alert. First dose is over, second dose is due, third dose is due, booster dose is due. So like that, we need to have an alert system. This is the 5th component of regulation. The 6th component of regulation is taking the truck and treating it in a scientifically designed treatment plant. That should be part and parcel of the regulation so that local authorities make arrangement for the treatment plant. Now, this treatment plant should have certain discharge norms, and that's what Dr. Banerjee will speak about it. Now, when you are designing or when your contractor is designing the treatment plant, he or she shall ensure that the discharge of solids and liquids coming out of the treatment should meet certain safety norms. In India, we call it as NGT, National Green Tribunal Guidelines, or part of the environmental acts. We don't have standards for biosolids. We don't have standards for sludges. We have discharge norms for water. We are working actually for national government and few others on developing standards for treated biosolids so that after treatment, it can go for agriculture or other applications. This is one of the plants which was designed, thermal system, pyrolysis, which will eliminate pathogens. However, that standards are not easily notified in many countries. So our regulations are still evolving. For water, for liquid waste, we have regulations, but for solids, we don't have clear regulations. So we are working on it. This is another example of a treatment. And as a part of the regulation, FSSM regulation, we also have a responsibility that on the part of the local government to do massive promotion. It is also called information, education, communication, for promoting periodic desludging, for promoting right kind of design of septic tanks, do's and don'ts. To summarize, these are examples that city authority has to do. Awareness creation. Why they should do it frequently. Why desludging should be done. It's part of the awareness. So to summarize what I spoke, for successful implementation of citywide inclusive sanitation and for achieving equitable sanitation, for achieving safe sanitation, and for ensuring that this service is available round the clock, you need to have a very clear policy intent, which all of our countries have drafted. Regulation. I have shared with you two different types of regulations. One is in situ for high-rise bulk waste generators. We call them as high polluters. We promote in situ. The second option is households, middle slum areas, individual households, where STPs and in situ treatment of through wastewater treatment is not feasible. We are going for on-site septic tank or leach pit system, and then promote a fecal sludge and septation management regulations. Like in Japan, Jokaso is an on-site system, but there's a part of the regulation, the sludge also has to be properly handled and treated and disposed. Whereas, like in Japan, where there is a high-rise building, in India right now, we are in Telangana where we are working, we are promoting in situ dewat systems or decentralized wastewater treatment systems for high-rise buildings and bulk waste generators. So that's the model of regulation that we are looking at. Now, what quality of standards that we need to meet in terms of discharge? Dr. Banerjee will take us through very systematically in terms of environmental standards and regulations. But before I hand it over to Dr. Banerjee, are there any questions or are there any comments that I should?
There are a couple of questions in the chat box, sir. Maybe we can take a couple of them.
So can you read out a few of them?
Yes, yes.
Or ask our friends to speak up so that they will switch on the camera and wake up.
So there's a question that came up while we are talking about the building regulation, is that what if the building owner does not follow the regulation? Does the owner get any benefit by following the framework?
Good point. So if it is a new building, then they will not get the permit if they don't create space for the on-site system, septic tank or whatever. They should have earmarked the space. It is like a parking space should be made available in a building. Like that, there should be space for toilets. Buildings should have, whether it is a small building, big building, we have what is called setbacks, building rules between the boundary wall and the wall. So these are called setbacks or building permit rules. In the building permit rules, on-site septic tank and the length, breadth and depth of that septic tank based on the occupancy of that particular property is defined in the auto approval system. It can be done manually also. But in our case, it is now embedded in the building approval system. If they don't submit, they will not get building approval. That is number one. Second, they may not construct after getting the building approval. So the town planning responsibility is to visit and check whether the buildings are built as per the approved building design and including the toilet. And if they don't, then they will not get the occupancy certificate. And they can also impose fines as per the regulations. So there are checks and balances. That is for the new building. For the existing buildings, if they don't set up on-site system or if they don't set up a STP, if it is a high-rise building, the regulation has the power to disconnect water supply the regulation has a power to disconnect power supply also under the EP Act. So they can't just mess up. They will not comply. That can't happen. So we need to, in the regulation, we need to create those incentives and disincentives.
There's a question. How is the public acceptance of reusing the treated water for their non-potable activities?
Excellent point. They are not using for potable purposes, number one. Number two, for non-potable application, the citizen, they may not even see the non-potable water because it is moving in the pipelines. It is a recirculation system. It is used only for flushing and chilling. And of course, for gardening. And if there is certain amount of nutrient in the wastewater, gardens also will grow well. However, we will ensure that some children play in the garden. We are ensuring that this treated water is properly ozonated or chlorinated as per the regulation. So acceptance is high because there is, in urban areas now, there is water stress. They have to buy water, expensive water, or dig tube wells to fetch water. Not every geography has water surplus. So because of that, there is a greater acceptance of the builder, and the tariff for these sort of buildings. Hence, there is a greater acceptance. It is not by default. Frank, over to you.
Frank, you may put up your question. Frank, are you there?
Okay, yes, I'm here. I just wanted to add that depending on the using of treated wastewater as for non-potable use, it depends on the way you will communicate toward people, explaining them, because there are no specialists of water, so they don't know much about water. So depending on the way we explain to them and tell them that it is safe, it is treated, and it is also reusable. We must not lose sight of reliable communication and communication toward the target people. Basing on this kind of communication, they will understand and they will adapt what we want. But also they will understand. They will understand. For example, I can take the case of Burkina Faso, where, for example, in one of my training, I assisted such thing, and it was in Ouagadougou, the capital town, near the waste treatment center. And we also reused the water from this center for gardening and also for trees. The local community living in this area, even today, they are doing so. But it was through communication that we made them understood it.
Thank you, Frank. I think you raised a very, very, very pertinent point. We need to have that effective communication for trust building. People don't trust easily. So I totally agree. For greater acceptance, you need a strong communication, but also we need to demonstrate and build the trust. The technologies have to deliver, because we have situations where the treated water has some color. So people are not comfortable to see that color in their flush tanks. So we need to communicate to them that this is okay for non-potable application. The point is very well taken, Frank, and it's integral part of the regulation. Communication is integral part of the regulation. Now, one of our friends from Nepal asked, whether this treated water can be used for groundwater recharge. Who will ensure the treated effluent meet the treatment standard? How often they monitor is my okay, always okay, fine. So, very important point you raised again. The treated water has certain amount of degree of pollution. It's not that it is distilled water. Now, the treated water, if it is sent through recharge pits, it's perfectly fine for groundwater recharging. But if I am taking a deep tube well into the aquifer and putting the treated water directly in contact with the aquifer, it is not acceptable in regulations here. It has to be through filtration of the nature. It can go through a rainwater harvesting pit. Through that, the treatment happens in the nature. So that is number point. Now, who will monitor all these things that we discussed? The monitoring has to be done by, if in Africa, luckily they have independent regulators, but we don't have a regulator. It is in the case of Telangana, Andhra, the service delivery agency, they have a separate unit for monitoring small properties. However, for big properties, the pollution control board, or it's also called as environment agency monitors. Environment agency monitors for high-rise properties, whereas for small buildings and other such properties, it is monitored by the city authority or a urban or local bodies. It's not a perfect monitoring, but it is monitored currently by the local bodies. Africa is much advanced in terms of having an independent regulator. That concept is yet to come here. Any other comments, Jyotsna, which I missed out?
No, sir. I think we have covered most, and a couple of them we have responded. So I think we can move on to the next one, next session.
So sanitary and insanitary, it is pretty clear. Sanitary, I mean, I would ask a couple of us, in the subsequent talk anyway, this will come. A sanitary toilet is one which is has the ability to treat aerobically or anaerobically the feces or the wastewater. If it is a twin pit toilet with proper leaching, it's a sanitation facility where one pit is used for a couple of years till it gets full. Then you use a second pit, you allow the pit to stay for a couple of months, and then you can evacuate it. But if you have a single pit, it becomes insanitary toilet infrastructure. Likewise, if there is a toilet facility without access to septic tank, but directly connected to the drain, it is an insanitary toilet. If there is a septic tank without having a soak away or a soak pit, technically it is an insanitary toilet. Shashok, is that clear? Okay. So I now invite Dr. Banerjee to take us through the environmental regulatory standards. And if many of you, if you are in the process of preparing them, we'll be happy to share with you so that you can look at it. You can adapt to your own context of how this sanitation has to be regulated in a citywide context. Over to Dr. Banerjee to speak on environmental regulations.
Thank you. Thank you so much, Mr. Chari, for having said that regulatory concept. And just give me a sec, I'll just share my screen on. Come back. Is my screen visible?
Yes, sir.
Yes, sir.
So the next few minutes, we would go through a little bit on the environmental standards, what are the parameters, what is to be done, and how do we generally test it, what should we focus on. And in the next few minutes, I'll try to put it in a very simpler words. It's some science, but then we'll try to put it in a simpler words. But then to begin with it, we need to know that how does a country act? Why aren't my slides moving? Slides moving.
You can just click.
Move.
Yeah. Okay.
Yeah, yeah. So when we talk about the environmental governance system, at the national level, we have the ministries like Ministry of Environment, Forest, and Climate Change. Then we have the Central Pollution Control Board. And below that, at the state level in India, we have the State Pollution Control Level Boards. Now, that's the pyramid we build on. That is the government systems, people we have, then there are these environmental acts which came up in different times. The first act that we came up in India was the Water Prevention Control of Pollution Act in 1974. Thereafter, there was a kind of amendment to that happened in 1988. A second round of amendment happened in 2003. And last year in June 2022, another committee was set up so that this Water Pollution Control Act could be further amended to the current needs of the time. Then we have the Air Prevention Control Act in 1981. We had an amendment in 1987. Then in 1986, along with the Central Pollution Control Board, we came up with the Environmental Protection Act, EPA Act. And then consequently in 1991, there was an amendment to that done. And finally, in 2010, we had a kind of a judiciary body, an apex body created by the Supreme Court of India called the National Green Tribunal. It's a quasi-judicial body which deals exclusively on environment-related civil litigations. So these are some of the acts which are related to water, air, environment, which we need to be as a part of this course, we needed to be very clear with. Other than that, of course, India also has other environmental regulations and acts like solid waste, on construction and demolition waste, plastic waste, e-waste, biomedical waste, battery waste, hazardous waste. All these are there, and time to time amendments have come up. Having said that, let's go back to that Water Act, or that 1974 Act. The Act is so strict in its sense that it clearly states that the state won't establish or take steps to establish any industry, operation or process or any treatment or disposal system or any extension thereto. There has to be a strict, it has to be strictly treated and discharged. And then these restrictions are so strictly implemented that even the government department is also taken into the provision of, if they violate any of these, they are also taken to the court. They are also liable to be taken to the court. That's how strict the Water Act of 1974 is in India, I'm talking of. So having said that, why do we do it? We do it because if we are talking of these treatment systems, we are talking of an act, we are talking of a governance body. Why are we talking it? To look into the fact that the ground and surface water pollution does not happen. The organics do not reach the surface water bodies or even the groundwater tables. What will happen if organics go? A lot of oxygen will be consumed to degrade the organics. The water body will be devoid of oxygen and the flora and fauna of the water would suffer. Nutrients would raise phytoplankton growth, algal bloom, what we've seen, one term is the eutrophication. Of course, Professor Chari was talking of pathogens. Pathogens is a huge source. This untreated water is a huge source of pathogens. All kinds of waterborne diseases, whether it is malaria, whether it is a stomach infection like typhoid, cholera, diarrhea, you name it, and it's mainly borne by water. So we need to look into these, that these do not happen. And to do these, sir was already talking to you that the septic tank, India has that IS 2470 standard, which that code of practice for construction of septic tanks. And this septic tank, if it's ideally constructed, it reduces certain of the pollution loads we generally keep on talking about biological oxygen demand, suspended solids. These are brought down by 50 to 60% of these if it's a properly constructed septic tank. Now, we did a kind of, before we got into the policy environment for Telangana, we did a kind of a small test in one of the cities of the public toilets and the septic tanks that were there. We did it in a city, we did several of these public toilets, we collected samples, and we tried to understand what is the pollution load that is coming out of the septic tank? What does this material contain? And if you see the red dotted oval line, if I talk of the chemical oxygen demand, it is in the range of 14,000. Biological oxygen demand almost 6,000 to 7,000. So that is the level. And look into the last row I'm talking of. Look into the fecal coliform. That is the microbes or bacteria which are responsible for all kinds of enteric diseases. While the standard says they should be less than 1,000 for water which could be used in agriculture. Forget about potable water. Potable water should be 0. Look at the number. It is in the 3.5 into 10 to the power of -7. In that amount, in that number of volume, these microbes are present. So that raises the this I brought to you just to tell you that that is the amount of pollution load that is there. The left-hand column are the different parameters I'm talking of: pH, chemical oxygen demand, biological oxygen demand, total solids, ammoniacal nitrogen, fecal coliforms. These are some of the chemical and the biological parameters. In the subsequent slides, I'll talk about them in a bit more details. And then in 2018, the state government of Telangana, one of the youngest states of India, came up with this policy on fecal sludge and septage management. And then these are some of the salient features of the septage management of PPE usage during handling of septage. What are the systems? Where do they need to dispose? Tracking of these disposal systems or the machines, vehicle fitness, licensing. You were talking of somebody, there was a question of licensing. These licensings, all these are part of this policy document which we have taken care of. And what do we do before we get into the construction of these fecal sludge and septage treatment, sewage treatment plants or sludge treatment plants? We go up to the Pollution Control Board, State Pollution Control Board, under the Section 25 of Water Act. They give us a site, they look into the site suitability where the plant is coming up. The treatment system design, they look into see that whether they are optimally designed and the discharge is meeting the set standards. And finally, what are we doing with that treated water? What is somebody doing with that treated water? Whether it is being discharged into the surface water body, whether it is being recharged, or whether it is being reused or recycled. Once those are certified, the plant gets constructed. And once the plant is again constructed according to the norms, designs, there is the PCB, the State Pollution Control Board, again goes back, does a kind of vigilance and comes with the consent to operate certification, where they look into whether each of these units are working properly. And finally, the designed outputs are met. And based on that, the plant becomes operational. So when do we say that? What does this fecal sludge actually constitute of? Fecal sludge is a mix of 97 to 98% of water, especially in countries like India, Bangladesh, of course. And there is very little amount of solid, 3 to 5% of solids. And then this will again be mixed up with variable other kinds of inorganic and organic contents like grease, grit, hair, debris, and all these will be a part of fecal sludge that comes up out of our systems. That let me take the example of septic tanks. They all come out from there. Now, There could be admixtures to that also, like if that septic tank is connected to our kitchen waste, if the kitchen water also goes there, if our bathroom wash, that is the washing machine, bathing water goes there. So those admixtures are also contributing to the fecal sludge. Now, let's get into, if this was an overall thing, then let's get into a little bit on the exact chemical or biological characteristics, what fecal sludge might contain, or what do we test on, what it has, what is to be treated, and how do we understand, well, the water is being treated, the solid is being treated. So we can bucket them into three kinds of characteristics. One is a set of physical characteristics where we look into the color of the water, odor of the water, the different kinds of solids like the dissolved solids, the suspended solids, the volatile solids, all these. Then we come into the chemical characteristics, the pH. We know pH, the hydrogen ion concentration. The chemical oxygen demand is like any water, anything which has some kind of salt dissolved in it will have a tendency to attract and use in oxygen dissolved in that particular water and finally oxidize the salts. So what is the oxygen demand? It is actually an indirect way of telling the pollution level, but then takes the power. A part of that chemical oxygen demand is the biochemical oxygen demand or the biological oxygen demand. That is, the microbes which are present in that particular polluted water or that untreated water, the microbes will also have a tendency to take up the oxygen to carry out their metabolism. So how much oxygen is being taken out by them? Now, when I'm talking of organics, these nitrogenous compounds, which are a part of our broken proteins, nucleic acids, they would be there. Phosphates would be there, sulfates, nitrates, from different sources, they would enter into this. And these are all chemical in nature, organic or inorganic, and we need to quantify them in the water, how much they should be and and there are methods to do that, laboratory methods to do that. Of the biological parameters, mainly the pathogens, whether it is bacteria causing different kinds of diseases, the viruses causes different kind of diseases, the protozoans, and of course we saw in the initial video that there is one more worm, which we generally talk and say worms, is the helminths, which are very stubborn pathogens which are there in this kind of fecal sludge. They all need to be treated. We need to make sure that they are not present when the water or the solid is being further reused, recycled, or discharged. So just to give you a range, this is a kind of a picture which shows, that circle shows the range or concentration of each of these pollutants, which we just spoke in the previous slides. This is the concentration. There's a high amount of concentration, if you can mark that this is the concentration that there is. And this needs to be treated before the water can be reused or the solids can be reused. Now, as I was talking of the physical characteristics, color, pH, DO is dissolved oxygen, electrical conductivity, which is a factor of the salts that are dissolved in water, the different kinds of solids, total solids, the suspended solids, the dissolved solids, the settlable solids, volatile solids. All these need to be estimated in the lab, whether it is for an untreated water, if you are doing it at the design stage when we are designing a fecal sludge treatment plant. And then once the treatment plant is operational, we need to check the output, the treated water, all these parameters that they have gone down to a certain level below the standards or meeting the standards. Then these chemical parameters, I told you, the pH, the hydrogen ion concentration, the chemical oxygen demand, as I told you, every salt, everything dissolved in water will have a tendency to attract oxygen, because every matter in this world, every element in this world has a tendency to reach its maximum oxidation state, to be in a stable state. I mean, well, many of you have gone through Oppenheimer, so you must be knowing a little bit of atomic chemistry right now. Everybody should be there. So that is there. Biological oxygen demand, I told you, that's the biological activity, the microbes that take up the oxygen. The total gel-dal nitrogen I'm talking of is the organic nitrogen content along with the ammonia nitrogen content that is there in the water. Phosphates, it could be in terms of total phosphates, orthophosphates. all these need to be monitored, because these, if they enter into a water body, these, if they enter into any other thing, they will contribute to the eutrophication of that particular water body, lead to more pollution. Of course, there are these classical laboratory-based methods by which these parameters can be tested. However, today there are these IoT or sensor-based methods also by which we can test the parameters in real time. Biological characteristics I was talking of, there are these classes of bacteria, Escherichia coli, which causes colitis, Salmonella typhi, now name tells you, typhoid, Shigella dysentery causes bacterial dysentery, Vibrio cholerae, the name gives you an indication what disease it causes. These viruses are there which again cause some kind of enteric diseases. Then there is the helminths, which are very stubborn, very difficult to kill, they stay for long, and then they stay up in the fecal sludge. One thing I would like to focus here on this slide to bring to your attention, we often have a confusion. Generally, we laymen have a confusion like, why are people talking of total coliforms, fecal coliforms, E. coli? What are these? So let me tell you, total coliform is a whole family of coliform organisms. Coliform is a family of bacteria, which this total coliform, when I'm talking of coliforms which infect humans, which infect cattle, which infect any other form of animals, That is the total coliform I'm talking. But when I'm talking of fecal coliforms, I'm talking of only the coliforms which have a tendency or the ability to infect only human beings, or they exist in the colon of only human beings. And of them, one of them is an indicator organism, which is always there in our system. And we call it, don't get scared, it is always there, but it is an opportunistic pathogen. Until and unless your immune system is very weak, this bacteria will actually do you good, give you some vitamins which you cannot otherwise synthesize. It synthesizes it in your intestines like vitamin K and all. But given an opportunity, it can cause a kind of disease, that is E. coli. So having said that, the other parameters, the chemical parameters I told you, they are very easy to, I wouldn't say easy, but there are very standard methods, standard chemical methods by which you can quantify them in the water content. But when it comes to these microorganisms, it becomes difficult that individually all these microbes can be quantified. So what we have taken to in the sense is we go into kind of indicator microorganisms. So when we talk of indicator microorganisms, when we talk of bacteria, E. coli, as I said, is the most abundant bacteria. So if it's in high numbers, there could be a probability that the other forms of enteric disease causing microbes may be there. So we have taken, we do an easy test for E. coli. Based on that, we can predict whether there could be other disease-causing microorganisms in that particular water. For viruses also, we take a total coliphage count, and based on that, we try to say whether there are other kind of viruses, disease-causing viruses that might be present. But when it comes to helminths, of course, still now we rely on direct visualization under the microscope and counting them under the microscope. But only differentiation we can do is whether it is a live cell or a dead cell. But this needs a little bit of time and skill. And of course, this is what we try to say about. That is, when we talk of microbial parameters, we generally go for indicative parameters. We are not directly hitting, because directly hitting, it needs a lot of skill. It needs a lot of huge sophisticated infrastructure, and it's also time consuming. So of course, all these need to be abided by some kind of, and I'm talking of a laboratory, there has to be a method of quality control and quality assurance in the laboratory. Then only when we report from that particular laboratory, the results will be accepted or believed into. So talking of the standards, these are some of the standards. I was talking of Central Pollution Control Board, which came in 1986. This is one of the standards. Central Pollution Control Board in India, if you see the 1986 standards, there are different columns for different kinds of usage, whether it is discharge for land or irrigation, whether it is, there is a column where we can use it for marine discharge, whether we can use it for surface discharge. This is a column where we have taken specifically for the FSTPs, where we are our design intent in the FSTPs is that they can be discharged in land, or they can be used in irrigation, more precisely in irrigation, horticulture, city beautification, all these kinds where the water can be used. So this is one. And then, of course, if you look into the NGT order, the National Green Tribunal I was talking of, the apex body, that has more stricter norms which is applied to some of the major cities. And if you see on the left-hand column, these are all same parameters I have been talking of. The color coding is nothing but, if you see the upper orange ones are typically some of the physical and chemical parameters. These are pollutant parameters. They actually indicate pollution. The yellow columns, if I'm talking of gel-dal nitrogen, dissolved phosphates, they are pollutants. Well, they are pollutants if they are in water, but when I'm talking of reuse, they can actually act as nutrients for the plant systems. That is the reason I said it could be used in irrigation. And of course, the green rows are the typical microbiological columns I'm talking of. So when we are talking of water, well, these are the standards. But as Professor Chari was telling you, there are no set standards for biosolids. So what we have done, we have tried to collate some of the international standards which are already existing. So we have taken up those solids like EPA standards or the WHO standards, and then we have to try to collate them, and we are trying to follow them. Now, when it comes, I was talking of nitrogen, phosphorus, potassium, all these phosphate, if they are present in water, they would be present in biosolids also. So after the treatment, this biosolid could be further used as a soil conditioner. If you remember, if you can recapitulate the video we were showing you right at the beginning, that the biosolids could be used as a soil conditioner. That soil conditioner, these components, these chemical components could actually act as a soil nutrient. So we have put them in this nutrient. And nutrients, what we are seeing, the numbers on the right-hand side, is the minimal level of number that should be there to qualify that particular biosolid, treated biosolid, to be used in the agriculture or horticulture purposes. The number could go above. Nutrients number could go above, but the base minimum should be this value. But when I'm talking of the other kinds of components, is this heavy metal, if you see, I cannot say that this is the number. When I'm talking of these heavy metals, I'm talking of this is the number that should be met, and the values should preferably be below these numbers. It can never go up above. If it is above, even a decimal point above, they cannot be used for any kind of reuse purposes. It should be below these numbers. Again, if I talk of the pathogen, which is the biggest concern with the biosolids, whether it is the bacteria, whether it is the viruses, whether it is the helminth of the Ascaris and Taenia, they should be well below the standard that has been set. It has to be well below the standards. So this is what the output standards for the water and the biosolids should be when the plant has been set up. Now let me give you a little bit of hint on what we did in Telangana. So as the US EPA says, that class A, when I call, class A is devoid of any kind of microorganisms. But in case, in this list, what we showed you, if there is any of the parameters, that is the left-hand parameters, if they do not comply to any of the standards set here, this will be classified as a class B biosolid. So the use in agriculture becomes restricted. That is the time a further tertiary treatment of that biosolids has to be done to eliminate out that particular pathogen content, and then only it could be reclassified or reused in the biosolids. The biosolids can be reused. Now, these are some of the defined reuse strategies for biosolids, whether it is in agriculture, soil rehabilitation, it could be co-composted, as you heard in the video initially. Some resource recovery in terms of, as I said, these biosolids have high amount of nitrogen, high amount of phosphorus. They could be recovered and then reused. mine rehabilitation, landscaping, carbon sequestration. All these are some of the potential uses of the biosolids that have been, of these treated biosolids. Now, just to give you, these are some of the way when we go on, when we develop an FSTP project. These are the different 4 major stages: are the bidding stage, the design stage, construction stage, and operation stage. And there, if you on the right hand side, if you see, there are these governing bodies and the different kinds of people who are different stakeholders who are involved at different stages. And finally, let me take you through, these are some of the FSTPs which when you come here in Hyderabad as a part of your sanitation tour, we take you through some of these FSTPs. These FSTPs are already functional. We have some 142 coming up in the recent. So 142 ULBs are coming up in Telangana, which are with these different kinds of FSTPs. Different kinds, when I say, I mean to say different technologies of treatment. We have not stuck to one treatment. We have taken up adopted different kinds of treatment technologies. But once this construction is done, we actually go through a kind of stringent laboratory testing, the report that has been showed to you here, and then only the plant is given a permission to operate on a regular basis. So this is in Khammam. This is a completely nature-based treatment system design, which is in Siddipet. This is a kind of geotube-based treatment, which is in Bodapal. And if you remember, Professor Chari was showing you one treatment in Warangal, which is a completely electromechanical way of treatment. Having said that, I'll come to a conclusion. But as I said, all these I said because, as Kelvin says, to measure is to know. If we cannot measure, you cannot improve it. So this is where I talked of the different parameters, different numbers that has been set for to meet the particular standard or the parameters. And now I leave it open to the audience for the questions if you have any. Thank you. Thank you so much. Yes, sir. Yes, Nazir Saab, boliye.
Yeah,
Nazir Saab, boliye.
Yes, thank you very much. But it's very tough for a man like me that I have no interest in science. So,
I know it's a bit heavy, but then
no, it's
we needed to be aware. You need not follow everything, but you need to be aware that these are the things that happen.
Okay. Well, Rasab, the city where I'm living, and at present we are with the ADB funded, the work is started for the fecal sludge management and sewage treatment plant. But the city is divided by mainstream. And basically a trend like all other South Asian cities, the sewer is directly go to and drop in this stream. And this stream is basically people perception that this stream water was very sweet 20 or 30 years ago, and people are used. No, it's like a sewage stream or the sewage stream. So how can we treat or even minimize the level of pollution in such type of condition? Thank you, sir.
Yeah. Just to bring to you what you were practicing 20 years back or 30 years back, all of us we are practicing. Let me tell you it in a very simple language, like what does your kidneys do in your body? Any idea? Whatever you take, your kidney actually acts as a filtration system. It retains the nutrients, it exudates out the pollutants or the toxins from your body. Right? That's what your kidneys are for.
Yes.
Right? So the same thing, Mother Nature has these water bodies which are her kidneys.
Okay.
So 20 years back, 30 years back, if you had let that polluted water into that water body, Mother Nature had that capacity with the volume and the concentration that was reaching. She had that water body had that ability to purify it to a certain level so that there was no problem with it. But with the rapid urbanization happening, with the rapid concentration of pollutants happening in that same water body, the volume of that water body has not increased, but the amount of pollutant that is entering the water body has massively increased, right? Same thing, what happens to our kidney? If I put too much of toxins in my body, my kidneys are bound to fail.
Yeah.
Similarly here, the water bodies are no way in a state that they can take care of the pollutants. So that is where these decentralized treatment systems are a need of the time, that you take the pollutant to this system, treat it to a certain level, and then if you let it release it to a water body, the water body is saved. The rest of the thing that can be taken care by the water body.
Yeah. Thank you.
Right. Yeah. Yeah, any more questions? Any more questions? I see a few more questions.
Yeah,
I think
we
in many
have
parts of
couple on
India.
the-
Yeah, let me read. Ashok
Okay.
Kumarji, you had a question. I think in many parts of India, every household have their own bores, submersible pump, and many person uses groundwater for multiple commercial activities like car wash and others. Strict guidelines for installation of bores are to be included. Yes, we are coming up with that. That is what Professor Chari was talking of on the US water management in Hyderabad. We are coming up with such a regulation where you would not be allowed to dig a bore and use the water rampantly. That is what we are coming up with. So we have another question from Nasir Saab. Was it the same question you put up, Nasir Saab, or this is a different question?
No. It's not a question that we have such regulation like the one you have in Bangladesh, in Pakistan, in India, but people are not knowing about them. Because we have very strong Water Act recently passed in 2020, and we have this environmental protection tribunal, and we have environmental protection magistrate. But I think we should.
So that is what Professor Chari was telling you right in the beginning, that it's not just having a policy or an act. It is a huge responsibility of ours to work out the information, education, and communication system so that each and every person is aware of it.
Yes, thank you, sir.
How storm water is treated. I mean, gray water, black water, storm water treated combined basis separately. Ideally, in a city context, if you are talking, sir, storm water, if it's purely storm water, it need not be treated because it is just direct rainwater which is going into the water body. But what we do in our countries, we mix the storm water drains with our gray water and black water. So if there is a sewerage system, it should ideally go to a STP, get treated, and then be discharged into the water. There was a question, does it have a guidance to ensure or check that FSTP is built and functioned in the needed extent? Absolutely, sir. Absolutely, sir. Mr. Thani, to answer your question, the FSTPs, we do, as I said, from the very first stage, we take hold of that. The land where it has been, is it ideally suited to construct with that FSTP, for that FSTP? The soil conditions, the air condition, all these things are taken care of. Then there, the concessionaire who is coming up with that particular FSTP shares a design and the output intent of that particular design, the technology he's using. We vet it out and then we let him construct. Once it's constructed, we do a kind of a trial run for a few months and we see whether the design intent is correct and the outputs that are coming up are as per the standards, and then only the consent for commercial operations of the plant is given. How you are managing rainwater, that's absolutely a different subject, Shahida ma'am. We are here mostly concerned with the fecal sludge and septage here. Rainwater managing, I don't understand. I mean, can you be, Shahida ma'am, you are already there. Can you open your mic and ask me what exactly do you want to know about managing rainwater? Frank, I'll come up to you after Shahida ma'am's question. Yes, Shahida ma'am, can you? If not, Frank, you can put up your statement. Yes, Frank.
Okay, so thank you. I have two questions. Number one, maybe I didn't notice it or I don't know. Are heavy metals part of the characteristics of wastewater?
When it comes to, you're talking about what kind of water?
Like, mercury and cyanide. if they are
So
part
let me
of wastewater
take the question. Okay, and any more questions?
Yes, the second one, what is your opinion about, I heard about wastewater treated in northern part of Africa, like Morocco, Algeria, Egypt, and so on. Wastewater treated treated and turned into purified water. I mean, drinking water. What is your opinion about it?
So, Frank, what I would do is here in this forum, I'll take your first question. The second question, you can put it up. We have some paucity of time. We have one more speaker waiting for us. So I'll take the first question and answer that. The second question, you can actually type it out in a WhatsApp group. We will try to have a conversation there, right? Does that work? Yeah.
Yes,
so
okay.
when you're talking of heavy metals, water coming out from domestic environment generally does not have a tendency of being contaminated with heavy metals, right? We don't generally use heavy metals much in our systems. And specifically, if I'm talking of fecal sludge and septage, we don't eat heavy metals, so we don't excrete out heavy metals also. So the concern for heavy metals is more with the STP sewerage systems, where there might be chances that some small industries or some other kind of polluting industries or a thing that the heavy metals as an effluent of that could be going. But if it is purely from a septic tank or from a pit latrine, there are very few chances that there would be any heavy metal. However, we have it when I showed you the standards, if you remember, heavy metals are a part of our testing regime also, whether it is the water or whether it is the biosolids. It is a part to ensure that it is not there or it is well below the limits. We do a testing of it, right? Having said that, if you people have any other very burning questions, you could put it up in the chat box, or you could actually put it up in our WhatsApp group. I would ask Jyotsna to please invite our next speaker, and then we will take it. Thank you. Thank you so much.
Right. Thank you, sir. And Ashok, sir, sorry, we are short in time, so you can put your question in the chat box. Dr. Banerjee will be responding. So now I would like to invite Miss Rosie. I hope she's there on the call. So she'll be taking us through some of the ISO standards that are implemented in Nepal, and she'll be explaining us about the procedure, what they have followed in implementing these ISO standards. Rosie, ma'am, if you're there, over to you.
Thank you so much, Jyotsna, and thank you so much, Dr. Banerjee, also the entire Ask team for this opportunity. So let me first then share my screen. So is it visible?
We are seeing your folder. Maybe you have to open it and share it again.
I have, but let me do it again then.
Yeah.
Is it visible now?
You can open the presentation, ma'am. We are seeing the folders.
Okay, I have already opened the presentation, but
you have to click on the presentation to share. While you're sharing the screen, you have to click on the presentation.
no, not yet.
Not yet. Or else do you want us to share?
Okay, okay.
I'll do that. I hope it is visible.
Yes, thank you so much. Thank you so much, Jyotsna. First of all, namaste, everyone. I'm Rosie Singh. I'm working as a project manager at Environment and Public Health Organization. It's an NGO, and it's been like 33 years that ENPO has been working in the sector of water, sanitation, and hygiene, also in disaster risk reduction and other various sectors. So my presentation would be on adoption of FSM ISO standard and its implementation in Nepal. So firstly, I will be sharing about the FSM ISO standard 24521 and 30500 and its adoption process in Nepal, and then what we have done for its implementation. For this, we have partnered with Nepal Bureau of Standard and Metrology. It's the standard body in Nepal, Kathmandu Valley Water Supply Management Board, Innovative Solution as a private company, and the project is being funded by Bill and Melinda Gates Foundation. Next slide, please. So we have this two major FSM ISO standards. You all might be aware or not, I'm not sure, but we have this ISO standard 24521 and 30500. But before moving on to this ISO standard, the context, setting on the context, as like in other many countries, in Nepal as well, we have this rapid urbanization as well as this population growth, due to which the sanitation is one of the major challenges for many cities, and out of that also fecal sludge management is the major challenge because it's not visible outside like other issues. It's hidden underground, so it's a big challenge for many cities, and it's posing environment and public health. And in this regard, we have the standards. Now the standards are the agreed upon ways of doing or making something. And we have all heard about this ISO. ISO is just network of national standard bodies and which delivers consensus-based global recommendations, which is developed by experts from around the world. Like there are more than 163 members in this ISO network. Next, please. And why a standard? This standard is basically protects human health, safety, and environment. It assures that all the relevant stakeholders which are working in the relevant sector they have these products as well as the services which are safe, effective, and reliable. It also facilitates dissemination of knowledge and good practices. And this standard also helps in facilitation of the innovation of the various products, also limits duplication of efforts, and strategic business tool to reduce cost by minimizing waste and increasing productivity. Next, please. Now, what is an ISO standard? It's the technical document which is representing international consensus of various experts and from various countries, basically on various aspects like performance level, operation, sustainability considerations, design, etc. Next, please. Now we have this ISO 24521, and Nepal has already adopted this ISO 24521, which is the guideline for the management of basic on-site domestic wastewater services. So this ISO standard, it covers throughout the entire sanitation value chain with primarily the four main key objectives. One is the public health and safety, occupational health and safety, or of whoever is engaged in this throughout the entire sanitation value chain, environmental protection, and for the sustainable development for sure. So next, please. This ISO 30500 is related with the product and for the prefabricated integrated treatment units. And basically, it consists of the two components, the front end and the back end. And as you can see that the front end is just the toilet facility, whereas this ISO standard, it covers the treatment units as that it also contains the treatment facility as the back end component in itself. Next, please. This is the prototype of non-sewer sanitation, or this the product which hopefully is expected to be in the market very soon, and many countries will definitely be will have the advantage of using this sanitation technology as the product. And also Nepal is also in the process of this adopting 30500 and also looking forward to implementing such products in Nepal very soon. Next, please. This ISO 24521 and 30500 goes hand in hand, and ISO 24521 basically optimizes existing wastewater services, whereas 30500 it encourages for the development of new technologies, for the innovation, and for the solutions in this sanitation sector. Next, please. Now, I'd like to briefly mention that how Nepal has been able to adopt this ISO 24521 and what are the major steps in adopting, so that this will be as the experience sharing for to those countries and to those professionals who are on the way of adopting this ISO standards in their countries. Next, please. To start with, please bear with me. I'm having a bit cold and cough. So for this, we have first established or formed the technical assistance team. And this technical assistance team comprised of water and sanitation governance advisor, service and business development advisor, policy advisor, technical advisor, and the standardization experts from Nepal Bureau of Standard and Metrology, which is the, as I said, which is the standard body in Nepal. And then we had this presentation and orientation to all these TA team members on ISO 24521 and 30500. Next, please. Then we had the formation of the technical committee at NBSM. For this technical team comprises of the members from various sectors, from urban, it includes from the universities to municipalities to government bodies. And the ISO standards is again briefed to the participants of the technical committee. And from that technical committee will then had this decision of forming the technical subcommittee, which will then further have the further discussions and presentations, thorough review of this ISO standard in the technical subcommittee. Next, please. As mentioned, the thorough discussion will take place in the technical subcommittee at NBSM. And for this, the document will be reviewed. Each and every what has been written in the document will be reviewed thoroughly, and then the technical subcommittee will then provide the recommendation to the technical committee for the adoption process. Likewise, for ISO 24521, the technical subcommittee provided the recommendation to the technical committee, and the final recommendation was then taken to the technical committee, which will then, next please, this technical committee will then have, according to this recommendation and approval of the technical committee, the ISO 24521 guideline was then adopted by the NBSM Council on January 2020. So it's, as we can see, but it's a very lengthy process. It takes like more than a year to go through this process, and this is the identical adoption, which means that nothing has been changed in the ISO standard, and everything what has been written in the standard has been adopted identically. But if the technical or the technical subcommittee wishes to have certain changes in the ISO standard, then that again needs to be discussed within the technical committee. But for in case of Nepal, it's the identical adoption. And for ISO 30500, it's in the adoption process. Recently, it has been approved by the technical committee, and it has been sent to the public hearing for almost like 2 months. Then it will be sent to the NBSM Council for the adoption process. Next, please. Now I'd like to share about the implementation of this ISO standard, basically on 24521. And this is the case of Mahalakshmi municipality in Nepal, that what we have done and how we have been able to achieve a few of the entire sanitation value chain. Yet there are works to be done, but we have made greater achievements. We have made achievements in Nepal, which is the first in Nepal, and it would be a great opportunity to share with you all about the case of Mahalakshmi municipality, Lalitpur, Nepal. Next, please. Mahalakshmi municipality, it was established in December 2014 with one of the municipalities in Kathmandu Valley. out of 18 municipalities, and 67.17% of the households rely on on-site sanitation. It has like almost 30,000 households in the municipality. Next, please. And this municipality, it comprises of 10 wards. And the major achievement we could achieve in this municipality is that we have been able to regulate the construction of standard septic tank in Mahalakshmi municipality. As in the previous presentation, as Professor Chari just mentioned, that the standard septic tank construction of these proper and the safe containment is the first step in the entire sanitation value chain. And without the construction of the standard septic tank, we cannot move ahead to achieve other components of the value chain. So in this context, Mahalakshmi municipality also becomes the first municipality in Nepal to not only to just to have the this regulation in the paper, but also in regulating practically in the field. Next, please. So the strategy is an action. The further slides will also compensate this. Will elaborate more this table. We had before moving on with this activity, we developed various strategies and actions that how we can move ahead with this achieving this major goal of the proper septic tank. So in this context, next please. So everything is I have just listed out here, but more elaboration I will make in the other presentation. Next please. So firstly, the key stakeholders and partnership, those were involved in this throughout this assignment or throughout this project, where one is the Nepal Bureau of Standard and Metrology, with which we partnered for the national adoption of these ISO standards, so that we can implement in the municipality and then pilot it in one of the municipalities, so that it can be replicated in other municipalities of Nepal as well. So we started with Mahalakshmi municipality, and with Kathmandu Valley Water Supply Management Board, we are working with the licensing mechanism of fecal sludge discharges, provide them the licensing mechanism to provide the license to dislodge and transport the fecal sludge. We are working with the private sector to strengthen the supply chain mechanism of proper septic tank, and then implementing this project in the municipality, basically for the ISO implementation, also to develop, form that or to develop the municipality as the model city for other municipalities. And we have also established IMIS in the municipality, worked closely with the community and city dwellers to raise awareness, and then collaborated with the various alliances and various network to advocate and then to amplify our initiatives, as well as to raise the awareness at the national and the local government level. Next, please. So before starting this project, we had this sanitation situation assessment. We conducted sanitation situation assessment in Mahalakshmi municipality. It is the census survey. We had the better understanding of the sanitation situation in Mahalakshmi municipality. So we have the entire household surveyed, and we have the information of the road network, about the sanitation situation, as well as for the about various aspects of that, about the building, about the sewer and the non-sewer network. So everything information we have captured through the sanitation situation assessment in Mahalakshmi municipality. Next, please. Then one of the findings which is related with this safe containment is that we had this, according to the survey, we found that like 55% of the households, they say that they have this proper septic tank, but we did not believe it, because so much of percentage with proper and the standard septic tank would not be possible. So we again had this sample survey of 400 samples out of this, and then we had the team mobilized in the field to go and check each and every containment, then we found that only 10.8% of the households had this proper septic tanks, and the others, those who said that they had the septic tanks, were just the holding tanks. Next, please. Then to start with, the first thing that is needed to govern everything is to bring the proper policy, the proper regulatory framework within the municipality. And as the local government is more powerful in developing with this, the policy itself. So Mahalakshmi municipality also is the first municipality in Nepal to develop this FSM bylaws. So FSM bylaws was it was developed in March 2020, and it's the first on-site sanitation legal instrument in Nepal. And according to this FSM bylaws, the municipality has now been able to regulate on the standard septic tank, because it's been the basis for the municipality to implement and then also to regulate the safe containment in the municipality. And with the achievement of Mahalakshmi municipality, we have also conducted orientation on citywide inclusive sanitation as well as FSM bylaws in almost 25 municipalities across Nepal. And then after the orientation and after the orientation on CYs as well as on FSM bylaws, the municipalities themselves have requested for the development of FSM bylaws 2 and 4. Now we have the request from almost 10 municipalities to develop this FSM bylaws, and which they are now in the process of the endorsement phase as well. Next, please. Now, on the basis of this FSM bylaws, what Mahalakshmi municipality has done is that it has included a 2-page guideline on standard septic tank and soak away system as the integral component of the new house design permit. So whenever any household they come to the municipality for the for the construction of the new house, then they have this 2-page guideline itself integrated in this application form, so that the detail of all the information of the standard septic tank is included in as the 2-page guideline in the municipality document. Next, please. The first and most important thing that we realized is that there has to be the dedicated unit and also the dedicated human resource in charge of carrying out the sanitation activities within the municipality, because in Nepal, the sanitation is the least prioritized, yet it's the least prioritized sector. And the sanitation issues are still not so prioritized within their other activities. But the municipality has been able to form a dedicated sanitation cell with a dedicated human resource, and also equipped the cell for providing the information not only to the visitors or to the citizens of the municipality, but also allocating the sanitation budget and also implementing the sanitation related activities throughout the municipalities is carried out through this sanitation cell. And what we have also realized and experienced is that if everything is institutionalized within the municipality, then it becomes easier to regulate and to implement any bylaws or to implement any policies, because while working 2 staff members, they have already changed in the sanitation cell. Some have left, and some have been shifted within the department. But as the system has been institutionalized within the system of the municipality, so whoever will joins the sanitation cell, it's still up and it's still running, and it's been easier now. Next, please. And with the leadership throughout the entire process, what we have done is that we have done all these activities with the leadership and with the ownership of municipal mayor, as well as all the ward persons of the municipality. So they have also developed this robust monitoring mechanism for standard septic tank construction. We have just facilitated them, but they have all worked out by themselves to develop the operationalization as well as the enforcement and for the monitoring mechanism, that how the standard septic tank regulation will be implemented and monitored. So all this mechanism with the active participation and ownership of municipal leaders, this has been possible. And we have just played the facilitation support, provided the facilitation support, and also provided the technical support for this conduction of such activities. Next, please. Now, as the result of this monitoring mechanism, what the municipality has developed is that they have developed the standard septic tank design and construction inspection flow diagram. Now, the standard septic tank is ensured at two levels. One is at the design level. Whenever the application is sent, then there has to be the design of the standard septic tank. It should be according to the standard one. So it's checked in the design, as well as it's also checked at the field level by field verification, by field inspection, and going into the field. And for this purpose, the municipality has also hired a monitoring focal person for this task itself. And previously, she is a lady, and then she shared that it used to be like very difficult to go and convince the households and also to go and check the standard septic tank. But after various capacity building programs, now it's being like the households, they are also now eager to learn and then implement at the field level. So the inspection is basically carried out at the design and the implementation at the ground level. Next, please. For all these activities, it's need to be added with the capacity building activities is the must. For this, we have carried out like the orientation on citywide inclusive sanitation and also to the FSM bylaws. And for this, all the municipal leaders, the mayors, as well as the municipal technical persons, engineers, ward chairpersons, ward members, they all need to be aware of this entire process. So they need to be capacitated at each and every step of what we are moving on. So for that purpose, we have this orientation programs targeted for particular groups. For example, for CYs and FSM bylaws to all the municipal leaders, then we had this training on standard septic tank design to the municipal leaders, and not only to the municipal leaders, it's very essential to have the training for the registered consultant designers and engineers in the municipalities, because they are the key persons who are responsible for designing the standards of the septic tank for the households. So we have this orientation and training to them as well. We have the training to the missions so that the construction of the standard septic tank is done appropriately, correctly at the field level. And also we had the training to the sanitation workers on occupational health and safety. Next, please. We also had the intensive awareness campaign. We conducted door-to-door campaign, and we also had this mobile booth campaign. But all these campaigns were also conducted under the leadership of the ward chairperson, because unless and until we have the involvement of the ward of the municipal leaders and the ward leaders, they will not have the ownership. So we have the involvement of the ward leaders throughout the process, and we mobilized the youth volunteers who actively supported throughout this campaign, and which was very, very successful, as a result of which the households, all the households and all the citizens, they are aware of the fecal sludge management, as well as about the
Rosie Ji would request you to wind up faster. We are actually run out of time, short out of time.
Sure. Okay, next, please. We have the containment improvement. For this, we have installed ready to install septic tanks in various to various targeted groups of the communities. Next, please. And the major strategy we used is that we have this, the municipality, it had this already electronic building permit system. And we integrated this electronic building permit system with IMIS, which is the information system for the overall information of the sanitation within the municipality. Next, please. Next, please. I'm not going this in detail. Yes. Finally, we have this app developed for sanitation as well as for the EBPS, electronic building permit system. And accordingly, the responsible person will go into the field and fill the information in the sanitation app, which will verify whether it's the standard or not. For this, we had this training on to the municipal staff members, and the inspection is carried out in the field level. Next, please. We have various publications and IC materials related with this septic tank, as well as about this bylaws and policy briefs. Next, please. Recently, we have also renovated one fecal sludge treatment plant in the municipality. So we'll also be covering the treatment service in the sanitation value chain, and will be updated in the IMIS itself. And through this project also, we have supported Kathmandu Valley Water Supply Management Board for the construction of 2 larger scale FSTPs in Kathmandu Valley, which will further support in providing the treatment facilities in the service. Next, please. So the key drivers of change is that have the strong leadership and commitment of the municipal leaders throughout the entire process. We need to have the participation of all the stakeholders, whoever will be engaged in this process. And if there is the evidence-based planning and interventions, then it is possible to achieve the change, as Mahalakshmi municipality has been able to make the change on the construction of the standard septic tank. And it's gradually being implemented and replicated in many other municipalities in Nepal. This ends my slide, I guess so. So next, please. If you have any information, or if you need any detailed information, then please feel free to reach out to me, or you can also get more information from info.org. Thank you once again to entire ASCII team for this opportunity.
Thank you so much, Rosie ji. That was such a wonderful presentation, and that's actually enlightening for all of us. And thank you so much for being here, and you're a participant and you took your time and gave us such an enlightenment. Thank you so much again. And then the documents she was talking of, we would upload some of the documents she has shared with us. We would be uploading it in the LMS system, so you can have an access to them. And of course, if you have any, we are not taking much time here. We are closing the session today. If you have any queries regarding that, you can always put up the questions in our WhatsApp group. She's there, a part of the WhatsApp group. She would be happy to answer, right, Rosie ji? Yeah. So yes, thank you so much. So